Okay, in this video, what we're going to do is fill in all the code for the Transform.CPP file and the Mesh.CPP file.
So I'm going to start with the transform because it's a lot easier.
You're picking on the easy one first.
Yes, I am.
All right,
so if we come over to our transform, notice we have almost nothing to implement here. Right. Let me just copy all of this and do what we've been doing for, well, every single class. And simply add our transform.h in, copy all of this in, and delete it, scope it. And let me just copy and paste all this into here, delete my virtual, and block it in. And the only thing we need to do inside of our transform constructor, if we go back here, remember we have a scale, a rotation, and a translate. Rotation of 0, 0, 0 is fine.
It's fine.
Rotation and translate is 0, 0, 0. It's fine.
Scale of 0, 0, 0, on the other hand, is not fine.
Because that basically shrinks our mesh into a point, and then we can't see it. So what we're going to do inside of our constructor is set our scale equal to a vector 3 of 1, 1, and 1. And this basically sets it to its default size. And the rest is really easy. All we need to do is for our set translate, do our translate.x equals x, translate.y equals y, and translate.z equals z. So, like so. And pretty much the same thing for rotation. So I'm just going to copy this entire thing. Change this over to rotation.
Yeah, it's rotation.
And for scale, same thing. Scale, scale, and scale.
Very nice.
So that's our transformation.
That's it. Simple.
Now let's go over into our mesh. This is a little bit more involved.
Not quite as simple.
Not quite as simple. But we'll start out in our mesh.h and do what we normally do. Copy over all of the functions that need defining. So let me copy this over to our mesh. Start with our include mesh.h. And scope everything we need in. And remove our area here. Kind of clean the spacing up just a little bit because it looks kind of, bad. And then let's just scope everything in. So, scope our mesh constructor, our destructor, our draw mesh, which reminds me, let me get rid of my default parameters here. Our get transform, our draw face, add vertex, add normal, add text chord, and finally our add face.
There you go.
So quite a few we have here. So let's start at the top. Basically, all we need to do here is call our root node. And actually, that reminds me, if I go back into transform, I think I forgot to, in our transform, remember, we need to call our roots constructor. So let me go ahead and add our node parentheses. And basically, this is going to call our nodes constructor as well. And that's important because, remember, that adds that into our global list of nodes, which is important. So if we come back over into our Mesh.CPP, we've added that without our semicolon. Thank you very much. And inside of our, which one do I want to start with? Let me start with add vertex. Okay. Start with some easy ones.
That's pretty easy.
So all this is going to do is push back a new vertex onto our vertices list, or I think it's a vector actually, simply by creating a new vector 3 and passing it x, y, and z. And then we want to return, you notice we have an int return value, and simply return the current what the current size of our vertices array is. So pass back, cast this vertices.size -1. Like so. Let me just copy and paste this for our add normal and add vertex since they're almost the same. So this is our normals and return normals.size. And for our mesh, UVs, I'm sorry. Yeah. Our UVs, we're going to pass it S, T, and for Z, we're simply going to always set that to 0.
Right.
And then our UVs, we're going to set that over like that. So with that, let me see if there's any other easy ones we can get out of the way.
Get
transform's pretty easy. So
return transform.
Return transform. And semicolon. Let me kind of pull this up just a little bit. Alright, so now let me go to add face.
You can do draw face. That's actually pretty easy.
Yeah, well, we'll do that right after add face.
Okay.
Yeah.
Only reason I'm changing around because they've seen this before.
Yeah,
You guys have seen. You're going to recognize this. Check it out.
All right. In draw face?
Yeah, no, we'll go and do...
Add face, okay.
That's fine.
So we'll push back a new face. And what we're going to need to do, let me just go into our mesh.h real quick. Remember we created this big, long constructor for our face. And all we need to do is simply pass in the pointers to our vector.
Right.
So our new face, vertices, and pass it v1. Our vertices, v2. Vertices, v3. And we're assuming here that the user does pass in the correct values. So you better pass in the right values, otherwise you can get an error. So our normals, n1. Normals N2, and normals N3. And then same for our UVs, so UVs UV1, UVs UV2, and UVs UV3. And simply end our parentheses off. And guess what? That's all there is to it.
Pretty simple.
And so now, as Bud suggested, we'll do our draw face. And this is really, really simple. If you've watched the OBJ loader, then this will look strikingly familiar.
Yes, it will.
But even more simple.
Right.
Since we're assuming that every single face has 3 vertices, it's a triangle, we'll do a GL begin, GL triangles, triangles, thank you, and GL end. And inside of here, we're going to loop through all 3 of our vertices. So for int I equals 0, I is less than 3, I plus plus. And simply do our GL text chord to F, in which we simply pass face, the face that we want to draw, its UVs, pass it I, and then get its X component, and face, UVs, I, and get its Y component.
Right.
And that's all there is to it for our texture coordinate. But then we have our normals. So our normal 3D, pass it our face, normals, I, X. Let me copy this because it's exactly the same.
For Y and for Z.
Mm-hmm. So if we need to change this over to Z.
That's right.
And this over to Y.
That's right.
And let me copy and paste this because it's even more similar for our vertex 3D. And this is going to access our vertices array. And there we have it.
Yeah,
so very, very simple.
So the bottom line is, for each draw face call, we simply create a single triangle.
That's right.
That's that simple.
That's simple. And then inside of our draw mesh here, we're going to basically loop through every single face that we have and draw those guys. But the first thing is, remember, we have our transform node. So we need to transform this particular mesh. But at the same time, once we get to the end of this, all we need to do is pop back our matrix. So let's go ahead and start out by doing our GL matrix mode and do a GL model view. And then at first we, of course, need to push our matrix.
That's right.
So do our push matrix, and at the very end we're going to need to pop our matrix. So do a pop matrix. But in between this, we could have lost our matrix mode. So I'll go ahead and set this over to our matrix mode and GL model view. Alright, so at this point we've pushed our matrix onto our stack so that we can save it.
We are safe to move things around.
That's right. And of course we have our transform node, so this step is very, very simple. We have our GL translate F, and we're going to simply call our transform.translate.x. Seems long, but it's really very, very simple. Simply calling our transform nodes translate and the X component of that.
So much easier, actually. This is so much more organized.
Definitely. So we have our translate. Let me just copy this for our scale as well. So our GL scale F, and pass it transform.scale.x, scale.y, and scale.z. And then we need to rotate around the Y, the X, Y, and Z axes. So do 3 GL rotate calls. So GL rotate F. The angle is going to be inside of our transformation node.
That's our theta.
And it's going to be in degrees.
Mm-hmm.
And then around our Y, X-axis.
X, that's right, 0 and 0. Good.
Let me copy and paste this 2 more times.
And all we need to do is change the X to a Y, and then that one to a Z, and then move over our 1, and again. Ta-da.
Very nice. So we've transformed our geometry into the correct place. Now let's go ahead and draw it. But there are a few things we need to check. Remember, we have a few parameters up here. Draw children, we don't have to worry about that just yet, but we do want to make sure that draw selected. If this is no, which it is by default, that means we simply draw ourselves and draw everything.
Right.
If this is not null, then we need to check to see if this, our own pointer, is actually this. Otherwise, don't draw ourselves. So let me go into here and do an if draw selected equals null, then we can draw it. Or if draw selected equals this, then we can actually block in our draw code. And our draw code is very, very simple. All we need to do is loop through every single face. And draw that particular face. So draw a face and pass it faces I. How simple is that?
That's pretty darn simple.
Alright, so a few other things that we need to do. So we've drawn our face. We also need to, well, come into here and draw all of our children as well. But again, that comes into our second parameter, draw children. So we need to say draw children, if draw children equals true. Now let's go ahead and draw everything. So we're going to do an iterator, as we've done many times now. So create an iterator, it, and we're going to loop through every one of our children. So do a children.begin, it does not equal children.end, and then it++. I just clean that up a bit. This is very simple. All we need to do is create our mesh, because remember, we're a child of Node, right? And to be able to access our draw mesh, we need to cast it over to a mesh. So we'll do a dynamic cast. And for those of you unfamiliar with this is something only in C++ that allows us to dynamically cast. It's the old way of casting would simply be mesh pointer like so.
Right.
Inside of C++, they typically recommend you use dynamic cast. So all we do is pass it our mesh, and then simply pass it our dereference of our iterator, which is going to pass into mesh. And if dynamic cast does not work, mesh is going to equal null. So let's check if mesh does not equal null. Let's go ahead and do our mesh, draw mesh, and pass it draw children. We know draw children must be true because we've just about to draw this guy. So set this to true, and draw selected, pass whatever was passed to us. So draw selected. And another thing that we do inside of here is you notice we're returning a bool. And basically, this return value is saying whether or not we've actually drawn us.
That's right.
Or any of our children. So what we're going to do is create a local variable called drawn, which is going to save whether or not we've drawn ourselves. So we're going to initialize this to false. And if we get inside of here and actually have drawn ourselves, then we'll set drawn equal to true. And then what we're going to do is come down to our children and say drawn, because remember, draw mesh is still going to return a bool value specifying whether or not our child was drawn. So we'll set drawn equal to draw mesh, and or that its return value with drawn, just in case it's already been set to true.
Okay, except go ahead and take that B out.
Thank you.
Okay.
And then after we're done, simply return drawn, which is our local variable that we've been setting.
Cool.
And with that, that should be everything. So let's go ahead and make sure this compiles. And it doesn't. Awesome. Oh, so basically what this is here is it doesn't recognize our OpenGL calls. So what we're going to do is basically include something that's going to allow us to, well, recognize these calls. So if I go over into our mesh.h, all I really need to do is include our GL engine.
Right.
So let me go ahead and include glengine.h.
Very nice.
And we're simply given one warning about the dynamic cast. Don't worry about it. Otherwise, everything seems to work fine.
Excellent.
So let me go over into our SDL demo and make sure this is getting called. Yeah, our CPP is getting compiled. So everything is good. It should be that all of the source that we've created is good to go.
Awesome. So with that, that's going to wrap up this video. Thanks.